Okay, hi everyone, welcome back to this video series on data center physical network topologies. Just as a topographical map shows the shape of the terrain, the physical topology of a network is also a type of map. It defines the specific characteristics of a network, such as where all the workstations and other devices are located, and the precise arrangement of all the physical media like cables. And though these two topologies are usually a lot alike, a particular network can have a physical and logical topologies that are very different. But basically what you want to remember is that networks physical topology essentially gives you the lay of the land, and the logical topology shows how data navigates through that layout. Here is a list of the various topologies you're most likely to run into these days: bus, star, ring, mesh, point-to-point, point-to-multipoint, hybrid. Bus topology. This type of topology is the most basic one of the bunch, and it really does sort of resemble a bus. The bus topology consists of two distinct and terminated ends, with each of its computers connecting to one unbroken cable running its entire length. Back in the day, we used to attach computers to that main cable with wire taps, but this didn't work at all that well, so again using drop cables in their place, unless you're dealing with 10-base-2 Ethernet, in which the case you would slip a T connector into the main cable anywhere you wanted to connect a device so to it, instead of using drop cables. Figure 1.8 depicts what a typical bus network's topology looks like. Even though all the computers on this kind of network see all data flowing through the cable, only one computer that the data is specifically addressed actually gets it. Some of the benefits of using a bus topology is that it's easy to install and it's not very expensive, in part because it doesn't require as much cable as other types of physical topologies, but it also has some drawbacks. For instance, it's hard to troubleshoot, change or move, and it really doesn't offer much in the way of fault tolerance because everything is connected to that single cable. The LAN that used a bus topology was replaced with twisted pair cable wiring called 10-base-T Ethernet, and advanced flavors of it are still in use today. 10-base-2 and 10-base-T, also referred to as classic CSMACD half duplex Ethernet. Star and extended star topology. A star topology's computers are connected to a central point with their own individual cables or wireless connections. You'll often find that central spot inhabited by a device like a hub, a switch, or an access point. Star topology offers a lot of advantages over bus topology, making it more widely used, even though it obviously requires more physical media. One of its best features is that because each computer or network segment is connected to a central device individually, if the cable fails, it brings down only that particular machine or network segment. That's truly a great benefit because it makes the network much more fault tolerant, as well as a lot easier to troubleshoot. Another great thing about a star topology is that it's a lot more scalable. All you have to do is, if you want to run a new cable or connect to the machine at the core of the star, in figure 1.9 you'll see a great example of a typical star topology. Okay, although it's called a star topology, it really looks more like an imaginary pictures people drawn on this of the sun. Yes, the sun is a star, but it definitely doesn't look like how we usually depict it, does it? You could always get away with saying it looks like a wheel with spokes connecting to a hub in the middle of the wheel and extending outwards to connect to the rim. And just as with that bike wheel, its hub It's the hub device at the center of a star topology network that can give you the most grief if something goes wrong with it. If that hub in the middle of it happens to fail, down comes the whole network. So it's a very good thing that hubs don't fail often, just as it is with pretty much everything. A star topology has its pros and cons, but the good news far outweigh the bad, which is why people are choosing to go with the star topology more and more. Here's a list of the benefits gained by opting for a star topology. New stations can be added easily and quickly. A single cable failure won't bring down the entire network. It's relatively easy to troubleshoot. The star topology has the following disadvantages. The total installation cost can be higher because of the large number of cables, but prices are constantly becoming more competitive. It has a single point of failure, the hub or other central device. There are two more sophisticated implementations of the star topology. The first is called a point-to-point link, where you have to have not only the device in the center of the spoke acting as a hub, but also the one on the other hand. This is still an extended star topology, but as I'm sure you can imagine, it gives you a huge amount of scalability. Another refined version is the wireless flavor, but to understand this version well, you've really got to have a solid grasp of the capabilities and features of all the devices populating the wireless star topology. For now, it's good enough for you to know that access points are pretty much just wireless hubs or switches that just behave like their wired counterparts. Ring topology. In this topology, you'll find that each computer is directly connected to other computers within the same network. Looking at figure 110, you can see that the network's data flows from computer to computer back to the source, with the network's primary cable forming a ring. The problem is the ring topology has a lot in common with the bus topology, because if you want to add to the network, you have no choice but to break the cable ring, something that is probably going to bring down the entire network. This is one big reason this topology isn't at all popular. You won't run into it a lot, as I did in the 1980s and the early 1990s. A few more questions include the fact that it's pricey because you need several cables to connect each computer. It's really hard to reconfigure, and as you've probably guessed, it's not fault tolerant. However, with all that being said, if you work at an ISP, you may find a physical ring topology in using the technology called SONET, or possibly some other WAN technology. You just won't find any LAN and physical rings anymore. The LANs that were used in the 1980s and early 1990s with ring topologies were token ring and fiber distributed data interface, FDDI. These LAN technologies no longer exist, but are mentioned in the data center CCNA exam objectives. Mesh topology. In this type of topology, you'll find that there's a path from every machine to every other one in the network. That's a lot of connections. In fact, the mesh topology wins the prize for the most physical connections per device. You won't find it used in LANs very often, if ever, these days, but you'll find a modified version of it known as a hybrid mesh, used in a restrained manner on WANs, including the internet. Often hybrid mesh topology networks will have quite a few connections between certain places to create redundancy backup, and other types of topologies can sometimes be found in the mix too, which is why it's dubbed hybrid. At any rate, it's full mesh topology if there isn't a connection between all devices in the network, but it's still respectively complicated. Figure 111 shows just how much only 4 connections can complicate things. As shown in the figure, things get more and more complex as both the wiring and the connections multiply for each n location or host, you end up with n minus 1 forward slash 2 connections. This means that in a network consisting of only 4 computers, you have 4 minus 1, 2 or 6 connections, and if that little network grows to say a population of 10 computers, you'll have a whopping 45 connections to cope with. That's a huge amount of overhead, so only small networks can really use this topology and manage it well. On the bright side, you can get a very respectable level of fault tolerance, but it is nice that we don't use these in corporate LANs anymore because they were very complicated to manage. This is the reason you'll usually find a hybrid version in today's WANs. In fact, the mesh topology is actually pretty rare these days. It's mainly used because of the robust fault tolerance it offers, because you've got a multitude of connections. If one goes on the blinks, computers and other devices can simply switch to one of the many redundant connections that are up and running. But as you can imagine, all that cabling the mesh topology requires makes it really costly. Plus, you can make your network management much less insane by using what's known as a partial mesh topology solution instead. So why not go that way? You may lose a little fault tolerance, but if you go the partial mesh route, you still get to use the same technology between all the network devices. Just remember, with the partial mesh, not all devices will be interconnected, so it's important to choose wisely the ones that are point-to-point topology. As its name implies, a point-to-point topology, you have a direct connection between two routers giving you one communication path. The routers in a point-to-point topology can either be linked by a serial cable, making it a physical network, or be far apart and only connected by a circuit in a typical WAN network, making it a logical network. Figure 112 gives you a prime specimen of a T1 or WAN point-to-point connection. What you see here is a lightning bolt and a couple of round things with a bunch of arrows projecting from them, right? Well, the two round things radiating arrows represent our networks, two routers, and the lightning bolt represents a WAN link. Part 2 of the diagram shows two computers connected by a cable point-to-point link. By the way, this should remind you something we just went over. Remember our talk about peer-to-peer networks? Good. I hope you also happen to remember that a big drawback related to a peer-to-peer network sharing is that it is not very scalable. With this in mind, you probably won't be at all surprised that even if both machines have a wireless point-to-point connection, the network won't be very scalable. You usually find point-to-point networks within many of today's WANs, and as you can see in part of figure 112, a link from a computer to a hub or switch is a valid point-to-point connection. A common version of this setup consists of a direct wireless link between two bridges that's used to connect computers in two different buildings. Point-to-multipoint topology. Again, as the name suggests, a point-to-multipoint topology consists of a succession of connections between an interface on one router to multiple destination routers, one point of connecting to multiple points of connection. Each of the routers and every one of the interfaces involved in the point-to-point multipoint connection are part of the same network. Figure 113 shows a WAN to best demonstrate a point-to-multipoint network that depicts a single corporate router connecting multiple branches. So here you can see figure 113, a point-to-multipoint network. Figure 114 shows another example of a point-to-multipoint network, a college or a corporate campus. Hybrid topology. I know I've talked about hybrid network topology back in the section about mesh topology, but I didn't give you the picture of it in the form of a figure. I also want to point out that hybrid topology means just that a combination of two or more types of physical or logical network topologies working together within the same network. Figure 115 depicts a simple hybrid network topology. Here you see a LAN switch or hub in a star topology configuration that connects to its host via bus topology. So I'm going to leave it here today for this video. If you like listening, please consider like, sharing and subscribing. Thank you.